So, you found yourself staring at a mountain of legacy Delphi code. You know, it kind of feels like it has its own language, its own way of thinking. Well, today, we're going to get inside its head. We're going to figure out how it handles data and memory, because mastering this one thing is the absolute key to not just surviving, but actually thriving in a Delphi environment. All right, let's kick things off with a little pop quiz. You see this line of code right here. It's simple, right? You're just assigning one dynamic array to another. Looks like a copy. But in the world of Delphi, this is one of the most common, most deceptive little traps you can fall into. So the real question is, what really just happened under the hood? And the answer is, surprise, you didn't make a copy at all. Nope, you just created an alias. What that means is both array 1 and array 2 are now pointing to the exact same chunk of data in memory. So if you change a value using array 2, guess what? You've also just changed it for array 1. This is a classic source of those maddening bugs that seem to vanish the moment you try to debug them. So what's the magic behind this? It all comes down to something called reference counting. You know, you can think of it like a librarian keeping a little tally card for a book. Every time you make an alias, like we just did, the librarian makes a tick on the card. The count goes up. When a variable goes out of scope, a tick gets erased, and when that count finally hits 0, Delphi knows nobody's using that memory anymore and it's safe to free it up. This is the secret engine that drives so much of Delphi's automatic behavior. Okay, to really wrap your head around this, you've got to know that not all data types in Delphi play by the same rules. They each have these distinct personalities, especially when it comes to memory. We're going to look at the 4 main characters in this story: dynamic arrays, records, classes, and interfaces.
And wow, this table just lays it all out, doesn't it? Take a look. Dynamic arrays and interfaces. They're both reference counted. That means Delphi is helping you out managing their lifecycle automatically. But then you look over at classes. A class variable? That's just a raw pointer. You assign one to another, you're just copying that pointer. And there is absolutely 0 reference counting. You are totally on your own. And records? They're the wild card. They usually copy the entire value, but as we'll see, their whole personality can change in an instant.
Let's really drill down on this difference between arrays and classes, because honestly, it's so important. The code looks identical, but the consequences are night and day. With the array, Delphi is your safety net, managing the memory for you with reference counting. With the class, though, it's all on you. You have to manually create that object, and this is the critical part, you have to free it. If you free the object using one variable, the other one immediately becomes a dangling pointer to garbage memory. That's not a bug, that's a guaranteed crash just waiting to happen. So let's circle back to our original problem. How do you get out of that alias trap? How do you make a real, independent copy of a dynamic array? Well, you have to be explicit about it. And here, the copy function is your absolute best friend. It creates a brand new, unique block of memory and just copies everything over. Now AR1 and AR2 can finally go their separate ways. So we've seen how Delphi's automatic helpers can be a little tricky, but it gets deeper than that. Sometimes they come with a hidden performance cost. It turns out that some of the most convenient features can also be the slowest. Great, and here's where it gets really interesting. Records by themselves are just simple value types. They're super fast. But the moment you add what's called a managed field, like a string, a dynamic array, or an interface, everything changes. The compiler suddenly has to throw out its super fast, highly optimized code and fall back to a much slower, generic method for doing things like initialization and copying. And believe me, the performance difference is not small. This chart says it all. Copying a record that's just full of simple stuff like integers, it's blazingly fast. But a record of the exact same size that contains managed fields, that copy operation becomes way, way slower. If this is happening inside a loop that runs thousands of times, well, that can be an absolute application killer. And what's the culprit? Well, for every single managed field inside that record, the compiler now has to run extra code to update its reference count. Yep, all that helpful automatic memory management we were just talking about, this is where you pay the price. It's that classic trade-off, convenience versus raw, unadulterated speed. But hey, it's not all doom and gloom. Now that we understand the problem, we can talk about the solution. And there is a really simple, elegant way to tell the compiler, hey, you can take a shortcut here. And it all comes down to one little keyword. And that keyword is const. See, when you declare a parameter as const, you're making a promise. You're telling the compiler, look, trust me on this. I'm only going to read from this data. I promise I won't change it. And in exchange for that promise, the compiler can work some serious magic. Instead of making a slow, full copy, it can often just pass a pointer. And for things like strings and interfaces, it can skip the whole reference counting overhead completely. So just how much faster are we talking? Well, in one test from the source material, just by adding the word const when passing a string to a function, the code ran 5.6 times faster. Let that sink in. That is a massive performance gain for adding just 5 letters to your code. It's got to be one of the highest impact, lowest effort optimizations you can possibly make in Delphi. So here it is, your cheat sheet. Anytime you're passing strings, interfaces, or big records into a method and you don't need to change them, make them const. It's not just a performance hack either. It's great for code clarity. It's like putting up a sign for the next developer that says, hey, this method reads, it doesn't write. All right, let's bring it all home. Understanding these rules isn't just about shaving a few milliseconds off your code. It's about fundamentally changing how you look at a Delphi codebase. It's about learning to think like a pro. Ultimately, it all comes down to this. Delphi is powerful because it gives you an incredible amount of control. It doesn't hide everything from you, but that power comes with responsibility. It trusts you, the developer, to know what's happening when you assign a variable or pass a parameter. It expects you to understand the rules of the game. So the final question I have for you is this. The next time you open that Delphi project, what are you going to see? Are you just going to see variables and assignments? Or are you going to see the underlying dance of pointers, the quiet ticking of reference counts, and all those hidden performance costs? Because seeing that hidden world, that is what it really means to think in Delphi.